All right, so today I wanted to look at the classwork for exponential and logarithmic equations. The first thing that I wanted to do was take expressions and be able to convert them. So what we're going to be doing is we're going to be converting from exponential to logarithmic. So the first one is 3 squared is equal to 9. 3 squared is equal to 9. This is in exponential form. We know that the base is going to be 3, the exponent is going to be 2, and the result is going to be 9. So I can make this into a logarithm. Now, the first thing to know about logarithms is that they're going to be written with a base. They're going to have something inside the parentheses. I'll just put x in there, and then y is going to be what's on the other side. So the base for this one, when we do 3 squared, is just going to be 3. That's going to be the base for our logarithm. And then what our result is 9. So I put that inside the parentheses. And then the y on the other side is going to be the exponent. It's going to be the exponent, which is 2. So what that's basically saying is if your base is 3, you have to have an exponent of 2 to get to 9. Okay, let's try number 3. 2 to the 5th power is equal to 32. Once again, we're starting in exponential form. You can tell because we have an exponent, right? It's 5. But the base is going to be 2. So when I go to do my logarithm, I need to give it a base of 2. Now the exponent, which is 5, it's just going to show up on the other side. So I put the 5 on the other side of the equal sign, and on the inside, I have the only number left, which is 32. I like to call that my result, because I know that 2 to the 5th power is going to give me 32. Okay, so for these two problems, we were converting from exponential to logarithmic. What I want to do for the next two problems is go the other way. I want to start in logarithmic and make it go to exponential. So we're going to convert from log to exp, exponential. Let's try 5. For number 5, I have a logarithm base 2 of 128 is equal to 7. Now my base for this logarithm is going to be the 2. So when I bring the 2 down, that's going to be the base, and my exponent is going to be on the other side of the equal sign. That's going to be that 7. And then what is 2 to the 7th power equal to? 128. That's the number on the inside of the parentheses. That's our result, right? Let's try number 7. For number 7, I have a logarithm base 3 of 81 is equal to 4. The first thing that I do is I have to figure out what the base is. For this one, the base is 3. So I bring the 3 down. The 4 is going to be my exponent on the other side. So 3 to the 4th power. And then the 81 is going to be my result in the end. So I get 3 to the 4th power is equal to 81. So that's going from logarithm back to exponential. So you can go both ways. You just need to figure out what the base and the exponent are. And then after that, everything else is easy. Okay, let's try number 9 and number 10. Those are the equations. So now I want to solve equations. What I want to do is start off with number 9. It tells me 3 to the x power is 243. 3 to the x power is 243. So this is asking me, what does x have to be so that 3 to the x power is 243? What number would that exponent have to be to make this true? Well, to figure that out, we need to take the logarithm of both sides. When we take the logarithm of both sides, what that's going to do is that's going to get rid of all the bases. So I'm going to take the logarithm of both sides. Now on the left side, I have 3 to the x power. That 3 is going to give me my base. So 3 is going to be the base for both of these logarithms. I put the 3 to the x power in this one, and I put 243 in this one. So that way I have both sides. What that's going to do is that's going to cancel out the two bases right here. The logarithm base 3 and the exponential base 3 are going to cancel each other out. And then whatever's the exponent is just going to be brought down, which is x. On the other side, I still have logarithm base 3 of 243. And that is the exponent. That takes 3 to 243, and that is going to be 5. So 5 is going to be my answer. Now, when we check this, what we want to do is we want to start off with the original equation and then go from there. So we started with 3 to the x power is 243. I'm going to let x be our solution, 5. So I'm going to plug in 5 for x, and I should get 243. And I do, because when I raise 3 to the 5th power, I get 3 times 3, 5 times. These 3's are going to give me 9. These two 3's are also going to give me 9. And then I bring down the 3. 9 times 9 is going to give me 81. Bring down the 3. And then 81 times 3 is going to give me that 243 that I want. So I get 243 is indeed equal to 243. So I get that true statement at the end. That's good. That's how I know that the solution 5 is going to work. So that's an exponential equation. I also wanted to try number 10, which is a logarithm. So for this one, the base is 2. So what I need to do is I need to bring down the base first. When I bring the base down, the logarithm becomes the new exponent. So I'm going to get 2 to the what power? Logarithm base 2 of x. And then the other side is going to become the new exponent for the same base, because I'm still going to have base 2, and the exponent is going to be this 4 right here. So what does that do? Let's concentrate on the left side first. Notice that the two bases are going to cancel each other out. The 2 and then the log base 2 will cancel each other out. And whatever's inside the parentheses is going to be brought down. X, right? And that's going to be equal to 2 to the 4th power. So what's 2 to the 4th power? That would be 2 times 2 times 2 times 2. That gives us 2 times 2 is 4. These give us 4, and then 4 times 4 is going to give us that 16 for my answer. So I know that X is going to be 16, and I put that inside my solution set. Okay, so to check my answer, what I want to do is I want to start off with the original, and that's log base 2 of X is equal to 4. I take this original equation, and then what I do is I replace X with a 16. So that gives us log base 2 of 16 is equal to 4. The only side I can simplify is the left side. Logarithm base 2 of 16 is asking me what exponent should 2 have to get to 16, and that's going to be a 4. So I get 4 is equal to 4 at the end. So that is how you check it once you know what the solution is. You just plug it back into the original problem. And that is it. That is exponential and logarithmic equations. I hope that helps.